Yes, hello?
Yeah, hello. As you can see me waving a sign for your time, so you're a good timekeeper, so I get...
Okay, hopefully. So it's 25 minutes?
Yeah.
All
Okay.
right.
So welcome to Andrés Cabrera.
All right, thanks very much. I'm very sorry I can't be there in such an important occasion, the first csound conference, but I'm glad to be able to participate in this a bit remotely. So I'm going to show you today Python scripting in qutecsound. So I'm going to talk about first a bit of Python in qutecsound. You can of course run a Python file externally in an external Python interpreter. Just open the Python file and run an external shell. Or you can use the new internal interpreter, which is already in SVN, and it's working, and some bits unfinished, but mostly working. You can use it in several ways. You can use it through the interactive console, or you can evaluate code from any editor or the new Python Scratchpad. I'll show you what I mean. So we've got these new little icons here on the new version. So this is the Python console and the Python Scratchpad. So we've got a full Python interpreter there, and you can execute any lines or any groups of lines from any of the editors or the Python Scratchpad. The default command is Alt-E, and everything will come up here on the main console. You can also evaluate scripts quickly from the scripts menu. You can set this on the preferences, and you can quickly run any of the scripts you have in that directory. You can, of course, edit them from here as well. You also have a convenient sectioning trick, a bit like what you do in MATLAB. Using a double hash, you can mark sections, for instance, like this. If you stand within the section and press Alt-Shift-E, it'll execute all of the section, and it'll show you what it has executed. As you see, the internal interpreter is currently a single instance, so all variables, imports, and all the state of the interpreter is the same, and it's accessible everywhere, no matter if you're doing it from one of the editors or the interactive console. This internal interpreter is implemented through the Python qt library, which is a library that exposes C++ objects dynamically into Python. And it has the additional benefit of wrapping all of Qt in Python. So you actually have all the Qt toolkit available inside qutecsound without the need of additional installation of PyQt or PySide. So you can simply do things like import python qt.qt GUI. This is the GUI module of Qt, and let's call it pqt. And then we'll say, well, I'll just run that, and I'll show you an interesting feature as well. It's now imported, and if I type pqt, it has completion. So I'm looking for qwidget. Just going to create a new widget, and I'm going to call it W. Bear in mind, these are Qt widgets, not qutecsound widgets. So it's a bit of a different concept. I'll set the geometry. Let's say this is X and Y, and width and height. And I'll just show it. So this is the widget I've just created. So you bring in all of Qt into qutecsound. How do you build support for Python Qt and qutecsound? You first need to get and build Python Qt from pythonqt.sourceforge.net. You have to make sure you match debug and release builds. If you mismatch those, there will be sort of very new strange crashes. So make sure you match the builds. And you need to add the config option to qutecsound's qmake line. Hopefully that'll get you up and running. Python Qt can be a bit tricky to build, so that's probably the hardest part. Don't forget, if you try it out and it doesn't work, email me and I'll give you a hand. So this is the interesting part, that I'm exposing csound into Python through the csound Python object. So there are many elements of csound and csound exposed into Python, and they are available by default in the interpreter through a variable called q. So if I go to the interpreter, just close this one for now. There's a variable called q, and you see that there's lots of things there. And there are many things related to csound, get file name, ksams. Many of these are things from csound, other from csound. This is what I'll talk about in this talk. So you have to be careful not to name any of your variables q, otherwise you'll lose the connection to this object. This q object wraps all the functionality from all the functionality wraps a lot of functionality from the qtsound interface, from qtsound widgets, from qtsound code editors, and also from running qtsound instances. So let's have a look at what you can do. There's a basic sort of transport control, and you can access any of the open documents. If you just if you don't give an index by default, it'll run it'll apply on the currently selected tab. Or you can give an index to affect any other tabs. For example, I can say q.play. This will start playing the currently selected tab, the simple subtractive synth. So there it is, it's running. If I wanted to run, say, this first tab, I would say q.play. That's index 0. If I come over to this tab, try it again. Let me see if this one's still running. Yep. Okay, I'll find out later why that didn't work. You can stop things. You can start hearing Stria on the background. Play it again. You can see that simple subtractive is still running. So you can order all of them to stop. And all of the running tabs will stop. Let's find out why it didn't work. I'm going to find the index of that document. And you can also set the active document. So let's see. Q.get document, and you just by name find its index. It's index 0. I wonder why it didn't work. Let's try it again. Q.play 0. Or something odd. Okay, we must have broken something last night. Okay. So you can get the document index and you can set it as well. If I set document 0, it jumps to the other. The subtractive synth is still running there, but you can control this with the interface and the active document. You can also manipulate csound qtsound editors. You can get the selected text and get parts of the text, like the CSD, which is everything between the csound synthesizer tags. You can get the full text, including widgets, cabbage text, CSLabs text, whatever is in there, or just sections like the org or the scope. So if let's go to a simple, this one. This has a short score, so it's easy to see. If I do q get score again, if I don't give an index, it'll apply on the currently active one. So there is. This is the score for this one. It's a Unicode string. That's why it looks a bit odd. But it's a string you can manipulate very easily in Python. You can get the widgets text or the selected widgets text. The presets text or things like the options text. it breaks things up for you in a very convenient way. Again, well, of course, an index of -1 will affect the currently active tab. You can also, I've just shown you querying the editors. You can also modify the editors. So let's stand somewhere here. And if I do q.insert text, the text will be inserted wherever the cursor is. I can also insert on other tabs. So if I insert that on tab 0, hopefully we should see that here on the csoundqt. You see, it's been inserted on that one. Let's unbreak it. Oh yes, but this is interesting. Since all these changes go through the normal undo redo stack, so I can easily another one. Insert hello world. So if I can undo those changes very easily. You can set the orchestra, the score. So this allows you full manipulation of the CSD file in a very convenient way. These are ones that I hope to finish, especially the widgets one, so that you can control and manipulate the widgets from Python. You can currently query them, but not write them. You can also get information on the document. File name. Or let's ask it for index 2. So this is simple subtractive. The second, or the third tab actually. You can also interact with the widgets. You can get and set channel values. You can get and set channel strings. All of the channels in qtcsound have actually 3 values, value 1 and value 2, which you can't actually access value 2 from the Python interface, and it only shows up in things like the XY controller. And you have a string value, so you can query those. And you can also set widget properties. And here you can change things like the size, the position, even the visibility of widgets. So let me show you how you can do that. Let's come here, and let's see this one. For example, this particular widget has channel frec. So if I do get channel value, just keep the name, I'll get the current value of that one, and I can also do set. And I'll set it to 100. And you'll see when I do this, this widget will jump to the value of 100. This can be interesting because it can allow you to do automation in Python. For example, let's say counter equals 10. And what can we do? For example, well, I'll show you later. I'll show you this later with a callback. That's better. And you can set widget properties, and you can even access some of the properties that are not available in the normal qtsound interface. So I'll set the property for widget with channel frec, and I'm going to set the property visible. These are the standard Qt, not qtsound properties, and I'll set it to false. And you'll see that it's not visible anymore. So these are things you can use. You need to bear in mind that these will not be saved, as these properties are not part of the widget format, but it's something that you can use for your interactive work. So that's how you get and set channel values and interact with the widgets. But it's important to note that this interaction is with the widgets, not directly with csound. So you have to be sure to connect csound to the widgets for this to work. So it's not automatic. You can, of course, create new widgets. You have create functions for all of the available widgets in qtcsound. So I'm going to create a new slider or a new slider. You just have to give the XY position. I'll give 50, 50. And there it is, that's the slider. You'll see that when you create a slider, you'll get back a string. This is the unique identifier for the slider. So you can actually manipulate the values. So using either the widget's channel name or the widget's unique ID. So you can say set channel value for this widget. And this is the widget's identifier. And I'm going to say the value is 0.5. So the slider will jump to 0.5. So you can use either the channel name or the widget's unique ID, both of them, to create any of the widgets. And you can automate creation, create 10 at a time, 20 at a time, whatever you need. So as I said, all functions return an internal unique ID. And it can be used instead of the channel name for the widget setter and getter functions as well. You can interact with the csound instance as well. You can get the qutecsound API version to make sure you have all the available things you need. And you can query the csound engine to find out the sample rate, the control samples, and the number of channels. So let's try it out. Get sample rate 44/100. Get csounds 128. If we check, probably this is 128. Oh, when it's not running, it might give you garbage, so you have to be careful with that. If I run it and try it again, there it is. You can also check if a no code exists. And although this is not drawn from csound, but from the documentation, they're probably in sync or very close. And it's designed more for code generation and syntax highlighting or syntax transformations or whatever, for, say, for code organization or things like that. So let's stop that one. And let's check if no code exists. It does, but oscillator doesn't. You can also, of course, send events, score events, to any of the running instances. So I've got simple subtractive running here. I'm going to send the event. You need to give it first the index and then the event. So the index is 2. And I'm going to make an event here for 40 and 100. This particular instrument takes frequency on P4 and velocity on P5. So there it is. This one's sounding. I do that again. We'll see that as we expect. You can also register a process callback. This isn't actually a callback, but it kind of works like that. So you can register any Python script to be run in between csound processing case a control block. That way you can execute any Python code in between all csound processing. So in fact, it turns out as a callback. So how do you do it? I'm going to show you how to automate something. So I'm going to call it callback. Here you see the usefulness of the Python scratchpad. You don't want to mess up your files, your CSVs, but you might need to create code that is more than one line long, which is what the Python console is good for. So the Python scratchpad lets you do that. It has syntax highlighting as well. So here you can access, of course, the Q object, set channel value, and I'm going to do frec, comma, I'm going to set an counter. and I'm going to add 10 to the counter. So what I'm going to do is send all of this to the Python interpreter. And there it is. So the Python interpreter now has this function called callback and the variable called counter. So what I'm going to do is register process callback. And I'm going to ask the Python interpreter to execute callback and execute it every 40 control blocks. So you don't have to do it on every control block. You can skip some. So let's try it out. We should see that the frequency knob start turning. Counter. Okay, let's just send this one to the interpreter. Wonder what's wrong. That's to unregister. You just register a blank process callback. You see counter. New spot here. I'll just send this one and let's check counter exists. Okay, yeah, it exists. Okay, that looks fine. I'm just going to send this again to the interpreter. Okay. And let's register the callback again. You see that the CSD is running. So, so you actually can insert the callback at any time. Down there, I don't know why. Interesting, yeah. Oh yes, of course, it's a local. You need to make sure you're using the global variable. And let's register it again. And we'll see this time the slider start coming up slowly. This is Python moving that. No. Okay, I'll register the callback. Okay, so that's what's done. And now there's the hard stuff, which is what's not done yet. One of the most interesting things probably is interaction with ftables. So you should be able to copy a table to a Python list and copy a list to a Python table, maybe just parts of the list into any part of the table, and vice versa, so that you can sort of play with the tables inside Python. But of course, that has several problems. You can't access ftables while csound is processing its buffer, because you have clashes and segmentation faults. So these functions must work through some kind of messaging system that sends requests to the performance thread, which then creates the data and fills and responds to the message. And the caller functions must wait for the real-time thread to finish that and then read the data and return. This is what SuperCollider does, and part of this has already been implemented in the CS per thread class, but there's still quite a bit of work to do, but it's something that would be really nice to have. And something I'd really like to do as well is interaction with live event sheets, so that you can use the live event sheets as visual matrices. You can get a sheet, and and you'll have the data in Python, and you can modify the sheets either from Python or graphically in a very seamless way. It would be very nice. What do I think this Python interface can be used for? I think it can be used for sequencer and notation applications, so you can read maybe the score and generate notation or score following, any kind of thing. It can be used to realize interactive pieces. I'll show in a second the realization of Koenig's essay by Marco Gasperini, and I wrote a little interface to run it in qutecsound using the new Python interface. You could also use it for automatic and visualization, for example, a graphical table editor. And you could even run csound inside Python to get the F-table, and then you can show it in an interface. And when you're done, you insert it into the code editors. You could also have things like visual patching interfaces, which can generate code on the fly or generate visual representations of the code. You can use it for designing custom GUIs and widgets. The widget's not available. You have all of Qt available there, so you can draw and define any kind of interface you need. And you can also do things like, or it can make easier to do remote control on mobile devices. I'm thinking you could, from Python, you select a group of widgets, you send the widgets to a mobile application, which then shows them. And this Python script can do all the connections automatically. So you just need to select the widgets, tell the Python script the mobile's address, and it'll do all the connections and all the interchange automatically. So it can be a very convenient thing. So before I ask you what you'd like to do with it, I want to show you the realization of Koenig's essay. So this is a little interface. This is Python running, and it generates this interface. This is a realization that follows very strictly Koenig's instructions and generates all these sections as if they were tape, and then splices them together and transforms them. So you can actually render all of these, and you see them there rendering. It'll actually generate almost 2 gigabytes of space on your drive, so be careful if you run this. And you can render it at any quality you want. And then after you're done, after they're rendered, you can actually open them in Audacity, open any of the parts or the final part. You have to finish the rendering in order for this to be available, but you can do things like that. I'll show you what the code for this looks like. So you'll see it's actually quite short. So this is the code, just defining the sections, stop render file, render files, check if the part has changed, edit, and here's just the creation of the interface. And that's it. This is done in standard csound code. So it's actually a pretty nice way to build interactive interfaces in Python. As you see, it's all using the standard Qt libraries and combo boxes and layouts, which result in a nice result. So I hope I'm doing the time. I hope I didn't go too fast. So here's my question. What would you do with it? Are you interested? Do you have questions, suggestions?
Yeah, Andres, this is Mike Goggins. I have a question. Did you try to import csoundqt in this environment and see if you could work it?
Actually, I haven't tried. I don't usually build csoundqt, but I don't see why it wouldn't work. It's a standard Python interpreter, so it really should work.
Could you import the csound API itself and run it from inside csound?
Yes, you can.
Okay, then csoundqt.
Not sure if you have it, if I have it installed, but yes, you should be able to do that.
All right.
Yeah, I think I've actually tried that, so yes, you can.
All right, thanks.
Yeah, thanks so much. Hi, Andres. Hello, how are you?
Hi.
It's Victor. My question, there are actually 2 questions, if I can remember. The first one is, what do we need to do, or whether we do need to do something about the CS Perform class, C++ class to support your tables adventure,
Sorry, I can't hear you very well.
Okay.
Just louder.
Just louder. Okay.
This is the microphone.
Okay, so maybe here. You know you were talking about the tables issue of queuing, putting a message queue and
Yes.
dealing with it. Do we need to do something to the CS Perform class to enable that, or can you do that from just the Python wrapper?
Okay, I'm not sure if I heard you correctly, but You're asking if there's anything that needs to be done in the csound API?
Yeah, in the csound perform class, whether we need to do something there to enable what you
No,
want.
I don't think that's a job for the perform class. I think that's all right. I think that can be a layer on top of the perform class, which handles that kind of messaging. And the way it can be done is having a lock-free ring buffer containing a structure that's filled outside the real-time thread and allocated outside the real-time thread. Then when the real-time thread finds it, it fills it while in between a perform calls the perform function, and it marks the structure as complete so that the caller can then retrieve the data and deallocate the data structures.
Yeah, but I understand that, but where do you put this code? Where would it fit? Would it be
Sorry?
Where would this code go?
I think this code could go in the CS per thread class, which is the performance thread wrapper of the csound API. I think that's where it should go.
Yeah, no, that's what I was asking actually. Whether the csound performance class, if the C++ csound performance class needs to have these add-ons to enable it. So that's where you're thinking of putting it on.
Yes, that's where I'm thinking it should go.
Yeah.
Yes.
Because there's already a message queue there for events. Maybe
yes, there is, and also for messages from the csound engine.
Yeah. And the second question is, we're now preparing a new release. Is this version of qtcsound without this Python scripting capabilities ready to be included in the new release? How's the status?
Yes, I think it is. I would consider it still alpha in the sense that it can still change. The API can still change, but I think it would be ready for release. Something you have to be careful, because if you send the interpreter into an infinite loop, it will send qtcsound into an infinite loop. But I guess if you're a developer enough to be delving in that, maybe, I think you can manage. But yeah, it's pretty stable already, but still unfinished. So I'm actually planning on distributing it with qtcsound soon. I'm not sure about Windows, because it will bring in the Python requirement.
I'm going to add it to the csound installer for the next release. There's an option to use Python or not. So if that option is enabled, I will put it into the qtcsound. But I need to understand something. The Python qtcsound is the same binary file, correct? In other words, there's two builds, one with Python and one without.
Yes, you can build that.
All right.
Do we have a question from the doctor?
Oh, it's all.
More questions? Okay, good. Thank you, Andres.
All right, thanks very much.